Anyway, and this idea of a neutron star, I know that some astronomers have given up on the neutronium business and want to talk about strange matter. Am I right on that? I think. Because they realize that there's some problems with the neutron. A lone neutron will decay in 14 minutes. And you say, well, that's all right because the pressure holds it all together. It seems to me you have to answer, you've got to go one or two ways. Either the neutron star sprung into existence at the instant of the Big Bang, which of course is not really possible, or it accreted. If it accreted, what kept the first 6 neutrons together until you get the 9th and 12th on there? So also there's this idea from nuclear chemistry of the isle of stability. If you plot the number of neutrons on the vertical axis and the number of protons on the horizontal axis of all the known elements, including the man-made ones, they cluster right together on that white curve. A neutron star is made up of neutrons only. That's a point on this vertical axis way up there somewhere. And it's well known that any isotope that's too far away from the green and the yellow will radioactively decay and go toward the white. So it seems to me that the idea of a neutron star has a lot of, as Lucy's husband says, a lot of splaining to do. Oh, these are just some facts that you can either agree with or not agree with, but I hope I've at least set the groundwork for them being the case. In the negative, magnetic fields are not frozen into plasmas, and I hope I've told you or given you some reason as to why that's true. Magnetic fields follow a closed path. They don't have any beginning or end. You can say, well, yes, you can have a curl-free magnetic field if there's no curl, if it's a straight, and that's the kind of magnetic field that's produced by a bar magnet. That's fine, but we haven't found any bar magnets out in space. So all of the magnetic fields we see have curl. And if they have curl, they're caused by a current density, Maxwell. I talked about the magnetic field lines. We're nose to nose with this problem. Let me just sort of tell you what I think, and you can argue with me afterward if you like. The idea of classic magnetic reconnection is that two magnetic field lines, like number 1 and number 2, approach each other. Why? Don't ask. They approach each other. If they approach each other and then they come together and they kiss at the center of that X, and then they break apart in the vertical direction and become 3 and 4. And, quote, because plasma is frozen into magnetic fields, onto magnetic field lines, as the lines, so the story goes, move from point 2 to the middle to 3, the plasma, according to the dashed line, is dragged along with it and thrown out into space. That's the basic idea of magnetic reconnection. Now, it's more complicated than that, but that's mainly it. I maintain there are 2 errors there. There ain't no such thing as a magnetic line of force in the first place. It certainly isn't an extant, real being in the cosmos that can do anything or push on anything. And B, even if you forget about the magnetic lines and talk about magnetic fields, plasma is not frozen into a magnetic field. So this doesn't work. And by the way, the only way you can get that sort of picture, this is one way to get it. Not the only way, but one way to get it. If you have 2 parallel currents given by the X's or the tail feathers of the arrow, there's 2 currents going into the board. The right-hand rule says there's a B field around each of these. And the center there of the little square box is essentially this picture here. Can you see it? On the right, the flux is up. On the left, the flux is down. The central point, this point right here, the point in the exact center of that box, if you stop to think about it, the current on the right produces a flux upward, vertically upward. The current on the left produces a flux, actually a flux intensity, H for the electrical engineers, downward. And obviously they're equal if the currents are equal. And these 2 cancel each other out. That's the reason that's called a null point. The magnetic field strength there is 0. Well, it turns out that the energy stored in the magnetic field is proportional to the square of the magnetic field strength, B squared. And a place like this that you can identify where B is 0 means there ain't no energy stored there. So how can you release energy from a point that doesn't store any energy? You can't. What you can do, and there's a tremendous amount of energy perhaps stored in this entire magnetic structure around these two currents, is you can shut off the two currents or just shut off one of them. All of a sudden the field collapses, and where does the energy go? Explosively radiates and brings along parts of the wire, and in cosmos the wire is plasma. So it drags the plasma and expels it. It's a possible explanation. It's Alfvén's explanation for the CMEs. Here's just this is this business. I don't think we have time to go into it, of whether the Earth's magnetic field is open or closed. I think you guys, just recently there was some question about that. If the interplanetary magnetic, the IMF, interplanetary magnetic flux is flowing from south to north, as it is in this case, the red dots are neutral points. But you notice that no member of the interplanetary magnetic field gets to go through the Earth. It's locked out by that configuration. In the case when the IMF is flowing from north to south, then the cusps are open and anything can get into the Earth. But as I understand it, it was within the last month or so, astronomers had discovered that even though this was what was going on, they discovered that something was getting through, and there's a big question now as to how that happened. And if the magnetic field is closed, how did this stuff get in here? And I don't know, but that's an interesting topic. My point is that if you're going to try to plot these lines of flux, go ahead and do it. But please remember that the lines aren't really there. They're in here. They're on the blackboard, but they're not in space. They don't really do anything. They can't, any more than Pinocchio can do anything, can cook your dinner for you. They can't. They're not real. Okay, just as to end up here, there are some cautions that I'd like to leave with you. One is electrical activity and its effects in space should not be ignored. I don't say they're all correct. I don't say they have the answer to everything. Of course not. But please just don't cast them off and say something like, oh, we've considered it, but it doesn't work. Oh, there can't be any charge separation in space. Don't say anything like that. Take a look and see what you think. The idea of new properties and mechanisms, open-ended magnetic fields, there ain't no such animal. That sort of thing. New science should not be invented until you take a look at all the old science. And I submit to you that people like Maxwell, Langmuir, Birkeland, and especially Alfvén have a lot to contribute to astrophysics. The last slide I have is to show you something that I picked up, and you can do it too. I think it's still there on the web, of an example of, I think, how if you don't understand the things that, not I, but Hannes Alfvén and Irving Langmuir have been saying for centuries, or at least for decades, you're going to get in trouble. Read this. In plasma physics, it is well known that magnetic field lines are frozen into an infinitely conductive plasma. Wrong. That's error number one. They're not. Two, since charged plasma particles are confined to circular orbits around magnetic field lines, well, all right, I'll let that one go because they are confined to circular orbits within a magnetic field, even though the lines don't really exist. That's not a bad error. This means that infinitely conductive plasma is wrong. There's no such thing as an infinitely conductive plasma. There's not a superconductor out there. They're good, but they're not superconductors. Will not diffuse across field lines and mix. Okay. Second paragraph. Conversely, two distinct field lines will remain separate since they cannot penetrate the intervening plasma. Okay, two distinct field lines will remain separate. Then how in magnetic reconnection can they come together and kiss? Now, the third paragraph, that's my punchline. I didn't want to show you that. In most cases, solar and magnetospheric plasmas can be described very accurately with such a theory. Really? Then how come tokamak hasn't worked in the last 60 years? Do they really know what's going on? Straightforward application of the theory would remove the possibility of ejected solar plasma penetrating the magnetosphere, since the plasmas would not be allowed to mix. Nevertheless, based on observation and known technological disruptions